In this video we are going to create a road with MDT, from a previously designed horizontal alignment. We start by generating the superelevations from the alignment, using the command with this name. We select the category of the road and leave the other parameters by default. We write the name of the superelevations file and accept. Now we check the superelevations graphically and check that everything is correct. Now let's get the long section. We select the alignment and keep the default parameters. Then we draw the profile with a 2 format in model space. We note that it has automatically created 2 sheets. We continue with the creation of cross sections. We indicate 25 meters as the length of each profile to the left and right of the alignment. We will also draw them in DIN A2 format, but this time in paper space, at 500 scale. We check that a layout has been created for each sheet. The next step is the definition of the vertical alignment, which in this case we are going to introduce manually. We run the Enter Vertical Alignment command, create a new file and type the station and elevation data for each vertex. We are now going to introduce vertical curves. To do this, we execute the Draw Vertical Alignment command. The drawing is done in model space with horizontal scale 1000 and vertical scale 1000. Then we execute the vertical curve command, enter the parameter of the 2 intermediate vertices and see that the rest of the data is calculated. We now begin to define the type section of the road. We run the command and see that a library of sections is displayed. We chose the urban section with 2 lanes and press OK. We select the alignment and an organized dialog is displayed with a series of tabs. We observe that the platform is automatically assigned roadbed and slopes with the values set by default. The graph shows the vectors of the platform in yellow and a simulation of the existing terrain in green with cut on the left and fill on the right. Our intention is to define a road in which the first 200 meters does not have a sidewalk and then continues a sidewalk with its curb until the end of the alignment. That's why we added a new line to the platform assignments and introduced the station 200. Now we delete the vectors of the sidewalk and curb with the delete key. Since MDT interpolates by default between the stations of different platform assignments in this situation, we will be interested in directly entering the station 200, the sidewalk already defined in the final station. To do this, we select the final station and press the duplicate button. Now it is necessary to change the behavior of the superelevation for certain elements. To do this, if we position the button on the header of any vector and press the right button, we have several options. We leave as superelevation enabled only lane 1, lane 2 and outer shoulder, and deactivate the rest. In pink these vectors are represented. Once the platform is defined, we see that we really only need 1 lane on each side instead of the 2 that appear. To eliminate the excess lanes, we place the cursor over the lane 2 column and click the delete option. We activate the roadbed tab and change the thickness of the roadbed by the value of 1 meter. Criterion: we change to slope to assign a constant value to the slope of the vector from the alignment. For the definition of the ditchway, activate the tab and press the insert button. In this case we are going to use the number 1 ditch, but we are going to add one more vector. Press the insert next button and assign the new vector the values for the increments on the x and y axes. Now it asks us for the station until which we are going to make the assignment. We activate the assignment by intervals box and set as initial station 100 and final station 200. It can be observed how the ditch appears drawn according to the indicated characteristics. Greater than to define the cut and fill slopes, we will keep the slopes assigned by default. Now we activate the plan view, which allows us to visualize how the defined road would look. In this case we have placed ourselves in the station 200, which is represented by a yellow line. Click OK to exit the section definition. Finally, we are going to define the widenings associated with the road that we are defining. To do this, we execute the command generate widenings. It asks us for the alignment and automatically generates a widenings file, according to the selected table. We can view the information of the widenings, and for this we execute the command list of widenings, selecting the file generated previously. Once we have defined our complete type section and the rest of the elements that make up the road, we can group them so that from this moment we work with a single file that includes them all. To do this, we create a new segment file. Then press the auto button and all the linked files are automatically imported. Now we can fully represent the project long section. In the menu we choose the command draw long section and select the segment file. We define the horizontal and vertical scale values, the labeling interval and the continuous format. Press the OK button and specify an insertion point for the drawing. After drawing the profile, we have detected an error in the parameters of the vertical curve of the grade. To correct it, we execute the vertical curve command and designate the vertex of the grade. We change the value of the kV and press the Enter key so that the rest of the values are recalculated. When validating the dialog and confirming, we observe how the drawing is automatically updated. We answer yes to the question about whether we want to update the associated segment. To draw the project cross-sections, we execute the command draw cross-sections and select the segment file. This time we select as paper format A0, horizontal and vertical scales 500 and draw in model space. Click OK and draw as many sheets as necessary to represent all the cross-sections. We observe that the drawing includes the existing ground, grade and roadbed, with the labeling of elevations and areas for each profile.